There are moments in science that change everything. Not the moments that make headlines, not the press conferences with smiling astronomers and pretty graphics. The other moments. The quiet ones. The ones that happen at 2 a.m. in a data processing lab when someone staring at a screen full of numbers goes completely still, pushes back from their desk, and doesn't say a word for a very long time. That moment happened sometime in late 2024. The James Webb Space Telescope, the most powerful observatory ever built by human hands, a $10 billion machine floating 1 million miles from Earth, was pointed at Alpha Centauri, our closest stellar neighbor, a star system so near in cosmic terms that it practically sits in our backyard. And what came back in that data stream was not what anyone expected. What came back was something that NASA's own imaging team flagged internally as, and this exact phrase appears in a leaked internal memo that circulated among astrophysicists in February, inconsistent with all current stellar models. They have not released the full data set to the public. They have not explained why. And the astronomers who have seen partial data are not talking. That silence, and that very specific, very deliberate silence, is the story. Because when NASA goes quiet, it is never about nothing. Alpha Centauri is not just any star. It is the dream. For generations, it has been the fixed point of every serious conversation about interstellar travel, about the search for life beyond our solar system, about humanity's future as a spacefaring civilization. It sits just 437 light-years away, impossibly far by human standards, but essentially next door by the scale of the galaxy. The system has 3 stars. Alpha Centauri A and B are binary stars, orbiting each other in a gravitational dance that takes roughly 80 years to complete. Then there is Proxima Centauri, a small red dwarf, the 3rd member of the system, and the single closest star to our Sun at 424 light-years. In 2016, astronomers announced the discovery of Proxima b, a planet orbiting Proxima Centauri inside the habitable zone. The zone where liquid water can exist. The zone where life, as we understand it, is possible. The internet went wild. Scientists called it the most important exoplanet discovery in history. And then slowly the conversation cooled. Researchers pointed out that Proxima Centauri is a violent star, prone to massive flare events that could strip away any atmosphere Proxima b might have. The excitement faded. Alpha Centauri moved back to the edge of public consciousness. But the James Webb Space Telescope never stopped looking, and what it found when it looked harder than any instrument in history has ever looked before is something the scientific establishment is not prepared to explain. To understand why this data is so significant, you have to understand what James Webb actually does that no telescope before it could do. Hubble saw the universe in visible and ultraviolet light, the light our eyes can detect, the light of stars and galaxies as we imagine them. Webb sees in infrared. It sees heat. It sees the cold, dark structures that are invisible to every other instrument we have ever built. It can detect the atmospheric composition of a planet 1,000 light-years away by analyzing how starlight filters through that atmosphere during a transit. It can see through dust clouds that have hidden cosmic structures for billions of years. And at a distance of only 437 light-years, essentially point-blank range for an instrument of this power, it can see Alpha Centauri in a level of detail that should, by every reasonable expectation, produce clean and explainable data. Instead, the data came back with what Webb's own team is officially calling unresolved anomalies in the infrared signature of the Alpha Centauri system. That is the sanitized, professional press release version of what happened. The version that circulates in private conversations among planetary scientists is considerably less calm, because the infrared anomalies are not random noise. They are not instrument error. They are structured. They repeat. And they are coming from a specific region of space between Alpha Centauri A and Proxima Centauri, a region where, according to every model we have, there should be nothing generating an infrared signal at all. Here is what makes this genuinely, scientifically extraordinary and genuinely, scientifically terrifying depending on your perspective. Infrared signals in space come from things that have heat. Stars have heat. Planets have heat. Residual warmth from their formation or heat generated by tidal forces, or heat from internal radioactive decay. Dust clouds have heat, warmed by nearby stars, but a structured repeating infrared signature in interstellar space, in a region with no known planet, no known dust concentration, No known stellar body. That does not fit any of those categories. The Webb team ran the data through every calibration check available. They eliminated instrument artifacts. They cross-referenced with archival Hubble data and ground-based telescope records going back decades. The signal was not there before. It appeared in Webb's observation window, which opened on the Alpha Centauri system in mid-2024 as part of a long baseline monitoring program studying stellar activity in nearby star systems. And when they pointed Webb back at the same coordinates for a confirmation observation 6 weeks later, the signal was still there, slightly stronger, still structured, still repeating on a cycle that the lead data analyst on the project, in a private communication later shared within the research community, described as disturbingly regular. Those two words, disturbingly regular, from a NASA scientist, about a signal from the direction of the nearest star to our sun. Let that sit for a moment. NASA has a protocol for anomalous data. It is not sinister, it is not a conspiracy. It is simply bureaucratic caution. When data comes back that doesn't fit existing models, the standard procedure is to hold it in an internal review queue, run additional verification passes, consult with external peer reviewers, and only release it publicly once a preliminary explanation has been established. This prevents the kind of media chaos that erupts every time an unverified anomaly leaks. The headlines, the speculation, the public panic that has to be walked back weeks later with a boring technical correction. Nobody reads. The protocol makes sense. But the Alpha Centauri data has now been sitting in internal review for over 6 months. 6 months. For context, Webb's data on the TRAPPIST-1 system, another high-priority nearby star with potentially habitable planets, was released to the public within 8 weeks of collection. The Proxima Centauri atmospheric analysis from 2023 was released in 11 weeks. 6 months of silence on Alpha Centauri data is not standard protocol. 6 months of silence is something else. And the researchers outside NASA who know about this, who have seen the partial data, who have heard the descriptions, who are connected to the people inside the room, are not writing papers. They are waiting. And in the scientific community, when everyone is waiting at the same time, it means someone at the top has asked them to wait. There is a concept in astronomy called the Great Silence. It refers to the Fermi paradox, the question of why, in a universe of hundreds of billions of galaxies, each containing hundreds of billions of stars, many of them billions of years older than our sun, we have detected no signal, no artifact, no unambiguous evidence of another technological civilization. The silence of the cosmos is one of the deepest mysteries in science. And for decades, Alpha Centauri has been the first address on our list. The first place we would look. The first place we would send a signal. The first place any civilization close enough to notice us might send something back. The Breakthrough Starshot Initiative, backed by Stephen Hawking before his death and funded by some of the most powerful names in Silicon Valley, was designed with a single destination in mind: Alpha Centauri. Tiny laser-propelled spacecraft, accelerated to 20% the speed of light, designed to reach Alpha Centauri in 20 years and beam back whatever they found. The project is still active. The engineering is still being refined. But in the last 18 months, something has shifted in the conversations happening inside Breakthrough Starshot's advisory board. People who attend those meetings have noted a new urgency, a new specificity. Questions that were once theoretical, what would we do if we found something, are being discussed as operational planning. Not philosophy, planning. And the timing of that shift lines up almost exactly with when Webb's Alpha Centauri monitoring program began returning data. The signal itself, and it is worth being precise here about what signal means in this context, is not a radio transmission. It is not a laser pulse. It is not a mathematical sequence beamed across space in a frequency we can decode. It is a thermal anomaly, a structured pattern of infrared emission from a location in space that should be cold, dark, and empty. In the search for extraterrestrial intelligence, SETI researchers have long argued that radio signals are just one possible communication medium, that a sufficiently advanced civilization might communicate or operate using methods we wouldn't immediately recognize as intentional. Waste heat from megastructures, structured gravitational wave patterns, modulated infrared emission from technology operating at scales we can barely imagine. The idea that an advanced civilization's presence might first reveal itself not as a message, but as an anomaly. Something that doesn't fit, something that breaks our models, something that forces us